Hello, everyone. Welcome to this live webinar. Thank you for joining us today. My name is Josh Arsenio. I'm the Director of Advisory Sales here at Security Compass, and I'll be your host for today's webinar. Before we get started, I'd just like to address a couple housekeeping items. First, recording of this webinar will be available after today's event. You'll receive an email with a link to the recording that's going to have all the slides and the audio track and everything. Second, if you have any questions, please submit your questions into the Q&A chat. We'll collect these and address them at least at the end of the presentation, if not during. And just want to make mention that we host webinars that dive deep into a variety of topics of cybersecurity, privacy, compliance, software risk every month. If you have attended any of our past webinars, welcome back. I do see some familiar names on the list. Thank you for joining us again. For those who are not aware of who we are until today, Security Compass was founded back in 2004 as a boutique pen testing consultancy. Today, we enable organizations to accelerate time to market for software development as you shift into a DevSecOps. We have SD Elements, which is our flagship product. Organizations can deliver software quickly, reduce costs through automation. We also have a modular role-based e-learning solution to empower organizations to embrace DevSecOps. And of course, our strategic advisory services. We have deep expertise in cloud security, pen testing, and red team, and everything there, all those variations on the theme. So for today's webinar, we're going to take a deep dive into common security issues associated with Docker containers and their implications on the DevOps pipeline. Pleased with me to have Aditya Gujar, who's a senior security consultant here at Security Compass. So please note that during the webinar, there may be a couple polls that pop up. If you're able to, please respond to these questions within a short period of time so we can keep things moving. But that's valuable insight that allows to make sure that we're speaking to your needs. And without much further ado, here's Aditya, and thank you for being here with me today. You can introduce yourself and take it from there. Thanks.
Thanks, Josh. Welcome to the part 2 of Attacking and Defending Containers webinar series. My name is Aditya Gujar, and I'm a senior security consultant here at Security Compass. I have around 10 years of experience doing penetration testing and security consulting. I got interested in containers when I came across Docker in a pen test a few years ago. That really got me hooked to learn more about this technology and its security implications. Since then, I have been following this topic closely and have created a methodology for our internal container security practice. In this webinar, we will learn more about the need for container security in modern DevOps pipelines. Then we will do a deep dive into most common attack factors in containers, and then review the best practices for mitigating those risks. We will then look at some of the available tools and industry standards for container security. Before we go into that, we'll begin with a quick recap of basics of container technology for those joining in for the first time. And this will also serve as a quick refresher for everyone else. Containerization is a technology that has existed for a few decades in various forms, but it has taken the tech world by storm in recent years. Basically, a container is a package that contains all the code and dependencies that the application needs for running. This allows the developers to focus on doing their job instead of worrying about other factors like compatibility, deployment, and so on. Containers run on top of a host operating system and share resources with the host. This allows the containers to remain lightweight while still providing all the needed support for the application. This also allows the containers to start up really quick as compared to virtual machines. Additionally, containers virtualize the memory, storage, CPU, and network resources at the operating system level, providing an isolated view of the operating system to the application. As more and more organizations are moving towards a more agile development cycle, the use of containers is increasing rapidly, which makes optimum use of infrastructure and allows faster application deployment, reduces the chances of errors during deployment, and fosters automation. These are some of the benefits that have made containers the preferred choice of deployment in recent years. With the rapid adoption of new technology, we must think about its security too, right? So let's do a quick poll here to see what the audience thinks. Awesome. In case of containers, there is a common misconception that because containers are isolated, they are secure. Well, this is not exactly true. Containers are not completely isolated because they share the kernel and many other resources with host operating system. Imagine in a cloud environment, same host can be running containers from different customers. So an attack on one host can compromise all containers running on that host. Containers also come with their own security configurations and settings, which introduce new attack vectors. On top of that, traditional security practices that are applicable everywhere are not applicable to containers because there's more complexity and the dynamic nature of containers. Another argument that we have seen people make is that we don't store anything sensitive in our containers, so why would anyone target us? Well, this would have been a good argument a few years ago, but these days anything on the internet is useful for malicious actors. Today, computing power is equal to money, and attackers target anything and everything available to them for crypto mining, spamming, or performing denial of service attacks. This is the reason every organization must take the security of their containers seriously. Now let's take a look at a survey performed by Tripwire in 2019. The participants were asked to list top concerns related to container security. And from the results, we can see that people had concerns about not having enough tools to perform security audit, or they did not know how to gain visibility into the containers to perform such audits. But above all, this survey highlighted that the lack of knowledge is the topmost concern when it comes to container security. In the same survey, participants were asked what could be the top reasons for security incidents in coming years. Most of the participants agreed that increased adoption of containers will increase the risk. As containers get widely adopted, it is obvious that containers will be used for some mission critical systems, and that will make an attractive target for attackers. Participants also thought that the lack of widely available security guidelines will be reason for security incidents in containers. This research was done last year, and the situation has not improved much since then. That being said, there are definitely more resources available now than ever. Let's do a quick poll here. Awesome. If you have answered other in this poll, can you please describe the reason in the chat? That would be really helpful for us to understand. Thank you. So before we dive deep into the specifics, let's take a look at the standard architecture of a container environment, the phases involved in it, and the components that make up this entire process. An image is where the developer defines what components will be installed within the containers, how to retrieve the secrets required for the application, how to perform its intended functions, and so on. Once the image is finalized, it becomes an immutable snapshot of the application. The developer will then push this image to a container registry. A registry is the place which holds your Docker images and their different versions. You can also set up your own container registry, which can act as your organization's own internal registry. There are also external registries like Docker Hub, Google Container Registry, or Amazon's ECR, which you can use in your DevOps pipelines. In the next phase, the orchestrator takes these images and converts them into containers. At this stage, administrators can configure runtime properties of containers and the strategy for deploying them onto the hosts. The last part of the architecture are the host systems, where containers are run. Host systems are mostly invisible to the end users However, it is a crucial part of the architecture. So what are the risk factors in this architecture? Well, each architectural layer of a container orchestration has its own security needs. Beginning with the image phase, there are risks which affect the container images. For example, the image may contain vulnerable or malicious components, and through these components, the security of entire environment can be affected. At the registry phase, there could be a misconfiguration that exposes all the containers in your private registry to the public. Nobody wants that to happen. Likewise, a misconfiguration at the orchestrator level can be really devastating as it deals with the runtime configuration of the containers. A running container, on the other hand, can be considered the most important risk factor amongst them all. This is the component which is exposed to end users and can act as a gateway into the entire pipeline for attackers. Therefore, it is imperative that your containers are running securely. And finally, the host which runs containers is also a risk factor you need to worry about. For example, missing patches on the host can allow a malicious actor to gain control of all the containers running on that host. Now let's take a look at each of these factors in detail. First up, images. A Docker image is created from a text file called Docker file, and it contains step-by-step instructions for Docker engine to build the image by running different commands. There are a number of things that can go wrong with this. Once an image is built, it can be considered as a snapshot of a system consisting of all the components required to run the application. So vulnerabilities can arise from any component within this image. If a crucial component of the image is missing critical security patches, then that impacts not just this image, but also any other image that is built on top of this. Let's say you are using a vulnerable version of PHP in your image. So every time you or someone else uses this image, the container will run with a vulnerable PHP version. On the other hand, an image can be free from all known vulnerabilities at the time of building, but a new vulnerability discovered in one of its components after the image is built will make the image vulnerable if it is not patched on time. Image misconfiguration is one of the biggest risks when it comes to container security. You can have the most up-to-date and vulnerability-free image, but a small misconfiguration such as leaving an OpenSSH server running within the container or running root user within the image can still increase the attack surface for your container environment. Hard-coded passwords is another major risk factor for images. A developer may create an image with hard-coded secrets like AWS tokens or passwords for quick and easy setup of the application, and then forget to remove those secrets before publishing the image. So now the secret will be visible to anyone using this image. And reusability of images is one of the biggest reasons why containers became so popular. You can find an image published by someone on Docker Hub that satisfies all your requirements, so you can just use this image instead of building it yourself. But how do you know if it is not containing anything malicious? An image from untrusted sources may have hidden malware or an attacker's code that mines cryptocurrency in your infrastructure. So how can you make sure your images are protected against these things? Always use minimal images that serve the purpose of running your app. For example, if you are not going to use most of the things offered by an Ubuntu-based image, then consider switching to an Alpine Linux-based image. Having a minimal image means you have less things to worry about. Because there are no bells and whistles included into these minimal images, you will end up with installing only the absolutely required external dependencies, and that will also enable you to keep the image updated as and when new patches are released. As an added benefit, the minimal images can also defer some of the attacks. Speaking from experience, while doing a pen test a couple of years ago at one of our tech clients, I was able to compromise a database running in a container. I had managed to execute shell commands on this container, but when I tried to use any other utilities like curl or wget, it did not work. because those were not installed. The container image they were using was very limited and minimal that prevented me from getting more access on their infrastructure. So the moral of the story is using minimal images helps. Then always use images from trusted sources only. This can be achieved by maintaining a list of trusted images and registries and enforcing the use of images from these sources only. You should prefer official images over images uploaded by random internet users. Docker Hub, for example, provides you a Docker certified logo next to the images, which they have tested for best practices, security, compatibility, and they've made sure that it is clean. Use of such images is recommended. Scan your images. This is very important. There are tools available to scan your Docker images for vulnerabilities, hard-coded secrets, and malware. It is recommended that you scan your images before saving them to the registry to ensure that you are not saving any hard-coded credentials or vulnerable components. And then after the image is saved, it should be scanned on a regular basis to ensure that there are no new vulnerabilities in any of the components of your image. These tools can also scan your images for insecure configurations that will alert you if you are running as root or exposing unnecessary services and many other misconfigurations. And I know we have touched upon this a couple of times, but it goes without saying, you should not store hard-coded secrets in your containers. Instead, you should be using secret brokers or secret management system to inject these secrets into the containers at runtime. There are third-party products like HashiCorp Vault or AWS Key Management Service that can be used to assign, manage, and rotate these secrets securely. Use of these mitigating factors is highly recommended for doing secrets management. The next factor is registry. A container registry is the place where anyone can store their container images and allows the users to pull images from it. You can also start your own private registry. In fact, it is very easy to set up your own registry. With the Docker image provided on the official website, registry can be set up and running within minutes. But the problem with that is it is very easy to set up an insecure registry. And to top it all, the documentation provided on Docker's website is focused more on getting the registry up and running quickly rather than setting up a secure registry by default. So this leads to a few registry specific issues. When an admin starts the registry, it is started without any authentication by default. Therefore, it is their responsibility to configure authentication on the registry. However, we have seen it is often forgotten. That leaves the registry insecure. And like authentication, the default configuration of the registry uses plain text protocols for communication. Because of this, any malicious user can simply perform a man-in-the-middle attack and alter the communication. And finally, there is the problem of untrusted registries. If an organization has not created a list of verified registries to pull images from, then the developers may use any image they find anywhere on the internet, and that will put their entire infrastructure in danger of malware attacks. To see how common this risk is, let us look at some case studies about publicly exposed registries. So by using keywords found on Docker's website, it is easy to identify if a host is running Docker registry. We also know that Docker registry started without authentication on port 5000 and 5001 by default, and it exposes an API for programmatic access. Using this information, we did a simple search on Shodan, and that gave us a list of 151 Docker registries exposed to the internet. So you can imagine how widespread this issue is. We have seen this number change weekly as more and more organizations set up their own private registries. Now let us analyze a real world case that happened a few years ago on a company owned by Twitter. A researcher was able to identify a private registry of a company called Vine using the techniques we just saw. And as suspected, the registry did not require any authentication from the user. So the researcher was able to list and pull images from it to their local machine. The images contained the application's complete source code, passwords, and other sensitive data. As you can see, a simple misconfiguration resulted in such a high impact breach. So how can you protect your registries? First, you must secure your private registry with proper authentication. Docker registry supports multiple ways to implement authentication. Using token-based authentication is recommended. Then configure your registry to work on secure communication channels. You can also configure your tools to connect to the registry only if the registry supports encrypted channels to prevent man-in-the-middle attacks. You should also consider whether putting the registry on the internet is really required or not. And if you are not setting up a private registry, then create a list of verified registries that can be used to pull images from. Once this is done, enforce the use of these trusted registries in all your development teams. Our next factor is the orchestration environment. The orchestrator is responsible for managing the environment in which containers run. So it has to be configured with different rules for users and roles, decide how to segregate network traffic within containers, and manage workloads deployed in containers. Authorization is a major risk factor when it comes to container environments. The root cause of these issues trace back to the early days when there was no concept of roles and everyone was given administrative rights by default, which is not exactly a secure design. The orchestrator is also responsible for managing the inter-container networking. Many orchestrators typically provide relatively open networking between containers. For example, in Kubernetes, by default, every container can talk to any other container on the cluster. So a compromise in one container can allow lateral movement inside the container network without restrictions. Similarly, when workloads of different severity levels are configured to run on the same host, one compromised workload can result in all other workloads getting compromised. To protect against these risks, the orchestrator should use least privilege access model, in which users are only granted the ability to perform specific actions on specific hosts, containers, and images that their job requires. For example, members of the testing team should only be given access to the images used in testing environment and should only be able to manipulate the containers they started. You should configure your orchestrator environment to separate the network traffic into different virtual networks. You can create separate virtual networks for your internal facing and external facing apps, so the traffic between them is not mixed. And if there is a need for communication between these two, it can be easily allowed through specific rules. Then you need to configure your workloads according to their sensitivity levels. One simple rule for that is you do not put workloads of different sensitivity levels on the same host. For example, if your organization has a public facing blog running on one host, it is not a good idea to put your main financial application on the same host. That way, even if the blog gets compromised, it won't affect other containers. And then keep an eye out for these things on a regular basis, because things change quite frequently in container environments. Our next risk factor is the container itself. As we know, a container is an instance of a Docker image. That means when you run the image you created, a container is created by the container engine. Now, even if you have made sure your images are as secure as possible by removing unnecessary software or libraries, making sure there are no hard-coded secrets, and so on, vulnerabilities can still crop up in containers due to other factors, such as vulnerabilities in the container runtime. Without going into too much details, a container runtime is something that is responsible for all things related to running a container. If there is a vulnerability found in this component, it can affect your entire environment. For example, vulnerability was discovered last year in a container runtime called runC that could have allowed a malicious actor to break out of the container and access the host operating system resources. These types of vulnerabilities are called container escape and are considered very severe. It is also possible that container runtime is not configured properly. A misconfiguration at this level can be very damaging, as it can allow container escape even if there is no vulnerability in the container runtime. For example, it is possible that the Docker socket from host is accidentally exposed to the container due to misconfiguration. When this happens, a container can easily use this socket to execute code on the host. So this simple misconfiguration can have a big impact in a shared environment. The applications running on the containers should also be considered as risk factors, because vulnerabilities within the deployed app can provide a gateway to the container runtime. For example, a remote code execution vulnerability in one of your applications can quickly escalate to a container escape with the help of a misconfiguration or a runtime vulnerability. And lastly, containers that were started during development phase but have since been forgotten can also be thought of as easy avenues for attacks. Usually, the containers started in development phases are not put through the same levels of testing that the production deployed containers go through. So the chances of containers being insecure are quite high, and it can put your entire environment at risk. So how do you protect your containers from these risks? You should be carefully monitoring the threat intelligence feeds to look out for any vulnerabilities within the container runtime that you are using. Patch and update the runtime if any vulnerability is found in that component. After all, containers are nothing but software programs, so they need patching and updating on a regular basis. Then look out for misconfigurations in containers. For example, make sure you are not running in privilege mode. You should also disallow containers from acquiring new privileges, so that once the container is started with fixed configuration, it won't be able to gain more privileges. Then perform regular security assessments on the deployed apps, so that there are no risks to the container environment from the deployed applications. And monitor your environment to make sure there are no unattended containers running. You can create separate environments for different stages of development, so that any container started during development won't affect your production environment. And the final risk factor in our architecture are the host machines on which containers run. As opposed to containers, host machines usually run full-fledged operating systems. This means they expose an attack surface that is quite large as compared to containers attack surface. And larger attack surface usually means more opportunities for malicious attackers. This also includes any components or libraries installed on the host. A vulnerability in any of these installed components will put the host at risk. We know that containers share the kernel with host operating system. So that is another factor which can lead to attacks on your container environment. A vulnerability in the kernel will also allow containers to escape the isolation and execute code on the host. The dirty cow exploit is one of the prime examples of these types of risks when it occurred a few years ago. And insecure file system configurations can also expose the host system to greater risk of file tampering. Let's discuss the tools that can help you audit your containers environment. Docker Bench is a security benchmarking tool which checks for dozens of best practices around deploying containers. Then Trivi is a vulnerability scanner for your Docker images that will scan the images for vulnerabilities in OS packages as well as best practices that we discussed. And Clear is a tool for performing static analysis of vulnerabilities in your containers. And finally, Sysdig Falco is a logging tool that will give you insights into your container environment so that you can easily monitor everything. So to wrap it up, we have discussed the most common attack vectors in containers, and discuss the best practices that will help you build secure DevOps pipelines. The security of container environment depends on setting up each component in a secure way, then scanning and monitoring all the things on a regular basis to make sure they stay secure. And if you're interested, you can check out our upcoming course, Defending Containers, that will go through these practices in much more detail. And that's all I have for this presentation. Thank you everyone for joining this webinar. I hope you enjoyed it and learned something from it. Please ask your questions through the Q&A window, and we will try to get to it within the remaining time. I'm going to hand it back to Josh.
Thank you very much. That was great. Really good detail there. This is just a reminder that this is the second part of the first series. If you did miss the first one, it is available for download. We'll make sure to get that link out to you, as well as the link to this recording. But just looking through our questions right now. First one is, you mentioned storing secrets in Docker images is not good practice. Is it okay if we are passing our passwords in environment variables?
Yeah, this is a really good question. So as per best practices around secret management, you should avoid storing clear text passwords in containers or on the file system. So by passing them on in environment variables, you are avoiding that, but there are some limitations to that. So you cannot pass bigger secrets like SSH keys or TLS certificates through environment variables. And you will have to resort back to storing them on the file. That will defeat the purpose. So to get rid of these limitations, you can definitely look into the secrets management tools. And that is the recommended way actually to handle secrets in your container pipelines.
Thank you. Looking through some of the other questions here. Is there any way to identify whether a website is running inside a container? How do hackers target such websites?
Yeah, that's really tricky. If you look at websites deployed in containers, it will look exactly like any other website. So from external point of view, it is very difficult to say whether that is running inside a container or not. But certainly there are ways to determine this once you get a vulnerability or you get something that definitely says this is a container environment, like an SQL injection vulnerability or a remote code execution. And once you are inside, you can look for files that are specific to container environments. Like there is a hidden file called docker env, docker env, that is present in all the containers. So if you see that file, that means you are inside a container. And there are other ways as well to look for determining if you are inside a container. Like if you can see the processes running inside a container, then the list will be very small because containers run pretty specific tasks that are required for running the application. So you can take a look at that.
Right, yeah, so it's very similar to any other kind of application or system fingerprinting. Of course, so once you get those telltale signatures, it's pretty trivial to start scripting something like that for large scale reconnaissance. Makes a lot of sense. So I have another question here. Are there any tools to automate SIS benchmark compliance? So there are a number of SIS benchmark standards that are published, including one for Docker. Is there any tools to kind of automate that compliance function?
Definitely, yeah. So remember the tool that I showed in the slides? It's called Docker Bench. It is actually based on the CIS benchmarks for Docker, and the tool is created by the company Docker based on the CIS benchmarks published, and I think it is up to the latest version of benchmarks. So that is a good resource for Docker. And for other orchestration environments, I think for Kubernetes, there is KubeBench, and that is provided by Aqua Security. That's also a tool that is updated quite frequently, and you can just use this tool on a regular basis to automatically scan your environment for all the CIS benchmarking indications.
There's another question that was kind of a variation on that, where can you automate whether or not there's hard-coded credentials? I think it's a bit of a mix between that answer, because there are a number of controls in the CIS benchmark calling on not hard coding. So is it safe to assume that the tool you just mentioned will also detect hard-coded credentials, or is that a bit more complicated?
To a certain extent, yeah, it can detect. But if you are worried about secrets going into the containers, then there are static configuration review tools as well that will do that for you. So every time in your pipeline, if it is getting deployed, before deploying the container, these tools can check the image whether there are any secrets inside the container or not.
Very good. Thanks for that answer. So that wraps up the presentation. There's no more questions in the queue. If you have one, feel free to drop it in now. Otherwise, feel free to reach out afterwards with any of the questions you may have. And of course, if you have any needs, we are a full consultancy that can help provide you some solutions, whether it be through assessments, cybersecurity assessments of various types, or just guidance so you can set up a secure environment and maintain it. Thank you very much, Aditya, and thank you everybody for joining us today. Please stay connected to our posts, as we'll be doing this regularly.